Now we're going to talk about the addition of an equivalent of water across an alkene. And so we'll use 1-methyl cyclohexene in this case, and we're going to add a net addition of a water across the double bond, and what we see is that we get an alcohol. So this reaction is regioselective, meaning that the alkene has 2 different carbon atoms and the hydroxyl group selectively adds to one of the carbons. And we'll talk about why that is. And this reaction doesn't just happen on its own. We also need to have some acid catalysts, such as a strong acid such as HCl. So the first step of this reaction is protonation of the alkene. So the pi electrons of the double bond come out and pick up an H+ from the HCl, or in this case, water and HCl will together make H3O+ with a Cl- counterion. But we protonate the alkene. And so when we protonate the alkene, we have 2 options: to either add the proton to the carbon that only has 2 bonds to carbon, or to attach the proton to the other carbon. And so if we just take a look at each of those structures, the first giving us a tertiary carbocation. So this is what we want to make. If we add the proton to the other carbon, we get a secondary carbocation, which is not what we want to make. So we make the tertiary carbocation. We can then have a molecule of water come in and attack the carbocation. The electrons of the oxygen attack the carbocation. And so we still have the proton that we added to the carbon, and then we also have the water molecule attached to what was the carbocation. So this looks a lot like our product, and so by simply either bringing another molecule of water or the Cl-, we can pluck off one of the protons and get our tertiary alcohol from the product.